Right. Unit 3, Lesson 4. So equations of intercepts and a vertex and a point. So you're determining the equation of a vertex from the vertex and a point. So we kind of did some of that already. But we can do it. The warm-up, I gave you a vertex and an A. And so now what this section is that you get a vertex and a point. So if we just look at this just real quick, I want you to we'll talk about the steps in a second. But if you look at this information right here, sorry, I got to put the thing on here. If you put this information right here, if I give you the vertex, what do you have of those letters? Nope. P and Q. So we have P and Q. And then if I give you a coordinate, another point on the graph, what do those letters represent? X and Y. So we have everything but A. And so we're going to solve for A today. So the short story, if you're given a vertex and a point, you have 4 pieces of information out of the 5. You're going to solve for the 5th. It's a single variable left over. Okay, so that's what we're going to do. And that's what it says here on the steps. Replace P and Q with the coordinates of the vertex. If you get the vertex, plug it in. So if you want to call this is plug-in vertex. Okay, this right here. Plug-in point. So you plug in vertex, plug in point, solve for A. And that's essentially it. Okay, that's all. That's all the craziness. Okay, but we'll work on it. See if we can make it less crazy for Brett. All right, so let's look at this here. Give it a little example. All right, so we have the graph of the quadratic function of the vertex -2, 8 passes through the point -1, 7. Find the equation of the function in standard form. So you understand, the only thing you're missing is A, because even when we write the function, we don't write X and Y, but A is what we need to have the complete function. Okay, so this is what you have to practice. Just if you get the question like this, just go, okay, this is my P, this is my Q, this is my X, this is my Y, and just put it in those spots. So Y is 7. I don't know A. -1 for X. The vertex is -2, so what do I put there? +2 squared plus 8. Okay, and I'll stop there and I'll take questions. That's the hard part today. That's all you're doing today. You're plugging it in, and we're going to solve for A now. Okay. This one gets kind of silly because what's -1 plus 2? What's 1 squared? So we just have an A there. Just goes to that. 1A, right? 1 times A is A. Right, so we subtract 8, and no one's got it. A is -1. That's it. So now we can write the equation in standard form. The equation would be y equals a negative x plus 2 squared plus 8. That's what it would be. We're done. What would that look like? So it's left 2, up 8. So it'd be right there. And it's going downwards. So it looks something like this. Okay. Now how could we rewrite the equation in general form? What could we do? Okay, so if you don't know this, all you have to do to go from standard to general is actually quite easy. It's a lot harder to go from general to standard, which we have a whole lesson on that. But we simply just FOIL this out and combine like terms. Okay, so x plus 2 squared, don't forget your pattern we learned. So leave the negative here for now. It's x squared, 2 times x times 2, 4x is in the middle. Remember, there's a middle. Don't do the silly thing of x squared plus 4 and be done. Okay, and then plus 4. Then we have a plus 8 out here. All of these get hit with the negative, right? And so then it's going to be -x squared minus 4x. And then -4 plus 8 is plus 4. So that's what it would be in standard form. What's that? That's tough, yeah. Told you today's not too bad, huh? Okay, let's practice using our calculator here to find the x and y intercepts. Okay, so let's go ahead and do that. I'll bring up my calculator here. Let me pause it. Okay, so let's go ahead and try it here. So let's go ahead and put in undo that. Put this, get this guy back up here. Okay, so we're going to put in our, you can put in either form, it doesn't matter. Let's just put in, let's put in the negative bracket, x minus 2, or x plus 2, excuse me, squared, and then plus the 8. Okay, I don't know if my window's any good. Yeah, my window's not going to be good. This is from earlier. Just a second. Negative. You can sometimes. Sometimes it over zooms. So I don't know. I usually like to start the. I like to start with the regular negative 10, 10, and then just adjust from there. Especially with our problems that we deal with mostly. If it's an applied problem where you're in the thousands, the zoom fit's probably good. But still, just kind of understand what you need to adjust. You know, if you need more on the left, you've got a bigger negative, etc. Okay. All right, let's. Yes, we're finding all intercepts. So there we go. We can see them all. We can see them all. Okay, we're looking at. This is what we're looking for. We're looking for here, here, and there. Okay. We don't have much work to do with the y-intercept because we can see it in general form, right? What's the y-intercept? We wrote it in general form there. The 4, right? The y-intercept's 4. So we don't have to do that one. These ones we need to do, okay? All right, so let's go ahead and do these. Just getting real good practice here. Second, trace the 0. Some of you guys still know how to do this. You should know by now. Okay, so we're going to move it over to the other side. Okay, enter. Enter. First one, negative 4.83 if you're rounding the nearest hundredth. Negative 4.83 is the first one, if you're going nearest hundredth like the notes say. All right, other side. All right, so recovered. So 2, 0, so now I'm going to the other side. Got to move your cursor over the hill. Okay, remember now I'm on the left of the 0, so I can hit enter right now. Now I'm going to go past it. That's the right side of it. Hit enter. And then get close to it. Hit enter. Positive 0.828, so positive 0.83. Okay. All right, we've got one more page is all, so let's just get this finished up here. All right. Okay, so find the intercepts from standard form. So find the intercepts is still the normal way, right? We know that we can use the equation of quadratic function written standard form to determine the x and y intercepts. Determine the exact values of x and y intercepts of the graph of function from standard. So we still know, if we just concentrate on x, if you're finding an x-intercept, you know that the y is 0. So we still do this. We still say y equals this, and we're going to solve for x to get our x-intercepts. So I'm going to add the 9. Divide the 3. Okay, everybody with me? Yeah, 9 over 3. Yeah, 3 over, I divided the 3, yep. Okay, then we're going to square root. So then we get root 3 equals x minus 1. And the last thing we're going to do, remember, it's plus or minus root 3. We're going to add the 1. So x equals 1 plus or minus root 3 is your x-intercepts.
Why is the plus or minus?
Because remember, when you square root, you have the plus or minus option. Okay, so that's more of a radical thing. Okay. And the other reason, too, is because, remember, they're symmetric, so they're going to work together, the plus side and the minus side. So that's also why. Okay, so now that's the x-intercept. The y-intercept's a little bit easier. What do we do for the y-intercept? You just put 0 in for x. So it's simply just for your y-intercept, it's going to be 3 times 0 minus 1 squared minus 9. 0 minus 1 squared is negative 1. Negative 1 squared is 1. So you essentially get 3 minus 9. Negative 6 is your y-intercept.
Why is it 1 like plus 1 or negative 1?
Where? Here?
Yeah. 1
Yeah, 1 plus or minus, because when you square root, you think about the plus or minus. That also takes into account because parabolas are symmetric. So for essentially, you're going to go 1 plus or minus from the middle. So they're the equal distance. That's why that does that. But just in general, when you square root something, it's going to be the plus or minus option. Just like when we were solving radicals. Remember, we have to go the plus or minus when we square root. It's that same idea. So I would just say, as in general, Parker, whenever you square root, put plus or minus in front. Okay. All right. The graph of the quadratic function is shown. The maximum point is shown. Find the equation of the function. So this again, we have everything we need based on our notes today to figure out what the equation is going to be. We have the vertex, and we have a point. Okay. So find the equation of the function in standard form. So it's going to be y equals a times x minus p squared plus q. My p is negative 1, so that means I put x plus 1 here. Okay, my q is 2, so it's plus 2 here. The point I'm going to use is negative 3 and 1, so I'm putting a negative 3 in for x. I don't know a, we'll find that. My y is 1, and I still have the plus 2 here. So now we're just solving for a. Negative 3 plus 1 is negative 2. Negative 2 squared is 4, so I have a 4a plus 2 equals 1. Minus the 2 to 1 gets me a negative 1. Divide the 4, negative 1/4. So a is negative 1/4. So now we're done. Okay, we know the standard form equation looks like this. There's your equation in standard form.
Where did the 2 go?
Which 2?
Right here, you had it 1.
Yep. Minus 2 is what gave us a negative 1.
So once you find the a using the points, then you just put it back to the standard.
Right. Put it in standard form with p and q in there.
Okay, but not the x.
Right, not the x and y. You leave x and y so it shows it's a function.
How did you know that negative 1 and 2 was for q and
Like how do you know difference?
It says the maximum point is shown. That's the maximum point. Okay, find algebraic the x-intercepts and the y-intercepts. Remember, the x-intercept takes a little bit more work. So the x-intercept, we're going to make 0 for y. We're going to solve this right here. Like I said, it's a little bit more work. So the first thing we're going to do is we are going to minus the 2. Okay, so you can do that. And how do we get rid of a negative 1/4? You times it by negative 4. So we're going to go by negative 4 here. If we do it by negative 4, that cancels. By negative 4 here. So I get a positive 8 now. So we have 8 equals x plus 1 squared. And we'll square root. So we'll have plus or minus root 8. You can minus the 1 there. So it's going to be x equals negative 1 plus or minus root 8. You could simplify root 8 to 2 root 2. Okay, that's fine as well. I'll leave it like that just for sake of space. So what I was saying is you can write it like this too from your unit 1. Negative 1 plus or minus 2 root 2. So the y-intercept in this one, plug 0 in. So we're going to plug 0 into our standard form we got just right here. So 0 plus 1 is 1. 1 squared is 1, so this essentially is nothing. It's negative 1/4 plus 2. So to do that, we got to get a common denominator, a little fraction work. 2 in terms of force is 8 force to get a common denominator. And so that means 7 force is our y-intercept. Okay? Okay. Good? All right, just the last piece here. Just this little bottom piece. I got to move it up for it. Say the domain and range of the equation of the and the axis of symmetry. So the domain of our parabolas we know is what? XER, right? Our domain is there's no problem with our parabolas. They grow this way and this way.